All right, so this problem reads, suppose a clay model of a koala bear has a mass of 0.2 kilograms and slides along ice at a speed of 0.75 meters per second. It runs into another clay model, which is initially motionless and has a mass of 0.35 kilograms. Now, because they're both soft clay, when they hit, they stick together. So what is the final velocity? All right, so this problem is all about an inelastic collision when two objects stick together. So when we're dealing with collisions, we deal with the idea of conservation of momentum, and that tells us that the initial momentum of the system is going to be the same as the final momentum of the system. So we have to do two things. We first have to identify what's initial and final, and then what's the system. So let's think about what really is that initial condition. And that'll help us define the system as well. So here's our clay model of a koala bear. Just go with me on that. I know that doesn't really look like a koala bear. And it's moving, it tells us, at a speed of 0.75 meters per second. And it's going to run into this koala bear. We'll say this is 1, this is 2, this is V1 initial, and V2 initial is at rest, so not moving at all, that second koala bear. So that's the initial condition, and it helps us conceptualize that our system is both clay models. Well, what about the final? Well, our final situation is these two have stuck together, and they're going to move off at some final velocity. And because they are, it's a little low for our video, because they are stuck together, they're both moving. 1 and 2 are the same. So we're just going to call that V final. All right. So the initial momentum is going to be the initial momentum of object 1 plus the initial momentum of object 2, both clay models in our system. That has to equal the final momentum of object 1 plus the final momentum of object 2. So our initial momentum of object 1 is mass 1 times the initial speed or velocity in the case of momentum. So we want to pay attention to direction. Plus m2 initial mass times the initial velocity of mass 2. Final is our m1 times the final velocity of object 1 plus object 2 times the final velocity of object 2. We know that object 2 starts off with an initial velocity of 0. So we're left on this side of the equation with just the system having the velocity, the momentum. The total momentum is only made up of object 1 initially. Now we also know that our two velocities are the same. So we can pull that out, and our final velocity comes out of the equation, and our masses can now add together. So this again recognizes that inelastic collision where the two objects stick together, kind of become one object with the masses of each one moving off together. All right, so let's put in our values. We have 0.2 kilograms, and it says it's moving at 0.75 meters per second. It's positive as I've drawn it. And that's going to equal our 0.2 object 1 plus 0.35 for object 2 times our V final. And when we solve for V final, we see 0.15 is going to equal 0.55 times V final, and we get our V final equal to 0.27 meters per second. So recognizing that momentum is conserved in this situation, recognizing what our initial and final conditions are so that we can use the law of conservation of momentum, realizing that the two have the same final velocity, and using our skills in conservation of momentum. All right, good job.